Hello children, our next chapter is chapter 10, straight lines. You have learnt about the basics of coordinate geometry in your earlier classes. Let's have a brief recall of coordinate geometry which you've done in earlier classes. To recapitulate the location of the points 6, -4 and 3, 0 in the xy plane. We may note that the point 6, -4, which is at 6 units distance from the y-axis, which is along the positive x-axis, and at 4 units distance from the x-axis measured along the negative y-axis. Similarly, the point 3, 0 is at 3 units distance from the y-axis and measured along the positive x-axis and has 0 distance from the x-axis. Let's recall some of the formulas which we used in coordinate geometry. Distance between the points P x1 y1 and Q x2 y2. So distance between these 2 points, which is square root of x2 minus x1 whole square plus y2 minus y1 whole square. Let's take examples. The point 6, -4 and 3, 0. Let P be 6, -4 and Q be 3, 0. Distance between these 2 points using this formula. So this one is x2 y2 and this one is x1 y1. So x2 minus x1, 3 minus 6 whole square plus 0 minus of -4, which is +4 whole square, which is -3 whole square plus 4 square, which is 9 plus 16, which is equal to root 25, which is equal to 5. Second one is section formula. The coordinates of a point dividing the line segment joining the points x1 y1 and x2 y2 in the ratio m:n, which divides internally. Then it is mx2 plus nx1 by m plus n, my2 plus n by 1 by m plus n. Suppose the coordinates are a is 1, -3 and b is -3, 9 internally in the ratio 1:3. Then we have to find the coordinates x, y using this formula. Here x1 y1 is 1, -3 and x2 y2 is -3, 9, and m is to n, which is m is 1 and n is 3. X equal to 1 into x2 is -3 plus n is 3, x1 is 1 by m plus n, which is 1 plus 3, 4. So we get -3 plus 3 by 4, which is 0. Then we have to find y. Y is m into y2. Here y2 is 9, m is 1. So 1 into 9 plus n is 3 and y1 is -3 divided by 4, which is equal to 9 minus 9 by 4, which is equal to 0. So the coordinates are 0, 0. Third one is midpoint formula. In particular, if m equal to n, then the coordinates of the midpoint of the line segment joining the points x1 y1 and x2 y2 are x1 plus x2 by 2, y1 plus y2 by 2. Fourth one is area of the triangle whose vertices are x1 y1, x2 y2 and x3 y3. Then the area of the triangle is half of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. For example, the vertices are given as 4, 4, 3, -2, -3, 16. So this is x1 y1, x2 y2 and x3 y3. So using this formula, half of 4 into minus 2 minus 16 plus 3 into 16 minus 4 plus minus 3 into 4 plus 2, which is equal to half of 4 into minus 2 minus 16, that is 4 into minus 18 plus 3 into 12 minus 3 into 6, which is half of minus 72 plus 36 minus 18, which is minus 54 by 2, which is equal to 27. If the area of the triangle ABC is 0, then the 3 points A, B, C lie on a line, they are collinear. If area of a triangle is 0, then it is said to be collinear. In this chapter, we shall continue the study of coordinate geometry to study properties of the simplest geometric figure, which are straight lines. The most essential part in straight line is slope. Slope of a line. A line in a coordinate plane forms two angles with the x-axis which are supplementary. The angle theta made by the line with the positive direction of x-axis and measured anti-clockwise, which is called the inclination of line. So inclination of line is the angle theta which made by the line with positive direction of x-axis measured along anti-clockwise direction, which is called the inclination of line. If the lines parallel to x-axis or coincide with x-axis, then the inclination is 0, that is theta is 0 degree. If the line parallel to y-axis or coincide with y-axis, then the inclination is 90 degree. If the line parallel to x-axis, inclination is 0 degree. If the line parallel to y-axis, then inclination is 90 degree. Hope you all understood what is inclination. Inclination is an angle which made by the line with the positive direction of x-axis in the direction of anti-clockwise. Then if theta is the inclination of a line, then tan theta, which is called the slope or gradient of the line, L. So if theta is the inclination of a line, tan theta, which is called the slope or gradient of the line, L. Slope of a line denoted by M. So M equal to tan theta, where theta is not equal to 90 degree. If the slope of a line whose inclination is 90 degree, that is if theta is 90 degree, then M equal to tan 90, which is not defined. And if theta is 0 degree, then M equal to tan 0, which is 0. Hence we can say that the slope of x-axis is 0 and slope of y-axis is not defined. Exercise 10.1, first question. Draw a quadrilateral in the Cartesian plane whose vertices are minus 4, 5, 0, 7, 5, minus 5 and minus 4, minus 2. Also find its area. Let ABCD be the quadrilateral with vertices A minus 4, 5, B 0, 7, C 5, minus 5 and D minus 4, minus 2. By plotting A, B, C and D in the Cartesian plane and joining AB, BC, CD and DA to find the area of quadrilateral ABCD, we draw one diagonal AC. Accordingly, area ABCD, which is equal to area of triangle ABC plus area of triangle ACD. Using the formula area of a triangle which is equal to half of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Area of triangle ABC. x1 y1, x2 y2 and x3 y3. So half of minus 4 into 7 plus 5 plus 0 into minus 5 plus 5 into 5 minus 7, which is half of minus 4 into 12 plus 0 plus 5 into minus 2, which is equal to half of minus 48 minus 10, which is equal to 58 by 2, which is equal to 29 square units. So area for triangle ABC, which is equal to 29 square units. Now we are going to find the area of triangle ACD. A is minus 4 and 5, which is x1 y1. C is 5 minus 5, x2 y2, and D is minus 4 minus 2, x3 y3. So using the formula, half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So area of triangle ACD is half of minus 4 into minus 5 plus 2 plus 5 into minus 2 minus 5 plus minus 4 into 5 plus 5, which is equal to half of minus 4 into minus 3 plus 5 into minus 7 minus 4 into 10, which is equal to half of 12 minus 35 minus 40, which is equal to 63 by 2 square units. So area of quadrilateral ABCD, which is equal to area of triangle ABC, which is 29 square units, plus area of triangle ACD, which is 63 by 2 square units, which is equal to 58 plus 63, which is 121 by 2 square units. Second question. The base of an equilateral triangle with sides 2A lies along the y-axis such that the midpoint of the base is at the origin. Find vertices of the triangle. Let ABC be an equilateral triangle with side 2A. Accordingly, AB equal to BC equal to CA, which is equal to 2A. Assume that base BC lies along the y-axis such that the midpoint of BC is at the origin. That is BO, which is equal to OC, which is equal to A, where O is the origin. The coordinates of C are 0, A. Coordinates of B are 0, minus A. It is known that the line joining a vertex of an equilateral triangle with the midpoint of its opposite side is perpendicular. Hence, vertex A lies on the y-axis. Applying Pythagoras theorem on triangle AOC, we obtain AC square, hypotenuse square, which is equal to sum of the squares of the other two sides. So AC square, which is equal to OA square plus OC square. AC square is 2A whole square, which is equal to OA square, plus OC square is A square. So OA square is 4A square minus A square, which is 3A square. OA is plus or minus root 3A, and the vertices of A are plus or minus root 3A, 0. The vertices of a triangle are 0, A, 0, minus A, root 3A, 0, or 0, A, 0, minus A, minus root 3A, 0. Thank you, children.